So we are going to continue on talking about logarithms. This is part 2, and we have a few objectives here. So we are going to understand properties of logs. We will use the change of base formula to evaluate logarithms, and then we'll use property of logs to write a given log as a sum, difference, and or product of logs. Before we continue, make sure that you have your calculator with you. You will need it when we get to the change of base formula, which is actually what we are going to start with. Okay. So properties of logs, change of base. So previously we talked that logs are the inverse of exponents, where if we have y equals log base a of x, another way to write this is a to the y is equal to x. So let's say you were asked to evaluate log base 5 of 8. So let's set it equal to y. So we would have 5 to the power of y is equal to 8. And we'd be asked to find y. Well, what can we raise 5 to get to 8? We know that 5, does it show up? 5 to the 0 is 1. 5 to the first is 5. 5 squared is 25. Okay, but there's no integer power that will give us 8. It's going to be between 1 and 2, but in order to do that, we'll need to use what's called the change of base and use our calculators. Okay, so change of base formula. So change of base allows us to use a calculator to find the value of logarithms. Okay, and the way that this works is if we're given log base b of m, we write this as log base a of m, where a is either going to be base 10 or base e, in which case we'd use the natural logarithm, over log base a of b. So this is what we're doing. We're changing the base to be base a, and then we're dividing log base a of m divided by log base a of b. So you can use base 10 or base e because of the calculator. Okay, so let's see what that looks like. So example 1. So find log base 5 of 8 using common logarithms, round to 4 decimal places. Okay, so the common logarithm is log base 10, but I'll also show you what this looks like to use ln. Okay, so going back from our formula on the last page, log b, and when you're using log base 10, you don't have to write the base there. So if you see something that just says log, that means that the base is assumed to be 10. Okay, so using change of base, we can write this as log 8. Notice I'm not writing base 10 because if I don't write it, it's assumed to be 10 over log 5. Okay, another way to do this would be ln of 8 over ln of 5. Remember that ln is log with base e. So you take out your calculator. I'm using the Texas Instruments, and so I do have a button that says log, and I have one that says ln. They are on the left-hand side. Okay, so I'm going to press log, and it does log, and then it opens a parenthesis. So 8, and then close the parenthesis, and then press the division symbol, click log again, and press 5. Okay, and I'm going to write this out. It's 1.292029. Okay, and if you did the same with ln, you would get the same answer. Okay, so now we're asked to round to 4 decimal places. So we go 1, 2, 3, 4. So we're rounding the 0. We look next to it. The number next to it is less than 5. So we keep it the same. So the final answer is 1.2920. Okay, with 4 decimal places, you do have to put the 0 there because there needs to be 4 places after the decimal. And what we talked about on a previous slide, we guessed it would be between 1 and 2 because 5 to the first is 5 and 5 squared is 25. Okay, so we can also go the other way around, complete the statement log 3 over log 2. Remember that the base is assumed to be 10 here, but using change of base going the other way around, okay, so the denominator is my base of the logarithm, and my numerator would play the role of x in our logarithm form. So this would be equal to log base 2 of 3. Okay, so let's get into some properties of logs. The first one is called the product rule. So we do relate it to exponents. Remember that logarithms are the inverse of exponents. So when we multiply bases with exponents, we add the exponents. So when we have something being multiplied inside the logarithm, we can change it into a sum. Okay, so log base b of m times n is equal to log base b of m plus log base b of n. So let's see what that looks like. Expressed as a sum of logarithms. So we will use what we just called the product rule for this. Okay, so 24 and 14 are what are being multiplied, and 5 is the base. So whenever you're rewriting logarithms as a sum, a difference, power, etc., you keep the base that you're given, unless you're using the change of base formula. Okay, so this would look like, this is my m and this is my n, so I'd have log base 5 of 24 plus log base 5 of 14. Okay, now you're not being asked to evaluate this or to find it, you're just being asked to write it as a sum of logs. So here is the sum of logs. Okay. For B, we have log base P of 13y. So when two things are written next to each other like this is assumed to be like 13 times y. Okay, so writing it, since we have multiplication, we can write this as a sum. So this is log base P of 13 plus log base P of y. Another rule we have is the power rule. So remember that when we raise a power to a power, we multiply the powers. So if we have log base B of m being raised to a power, we can take that power and multiply it times log base B of m. Okay. You don't necessarily aren't required to know how these relate to the rules of exponents, but it could be helpful as you're working with them to see that connection there. And if you want me to go into more detail, I'm definitely happy to do that with you. Okay. So express as a product. So we have log base 2 of y to the 7th. So 7 is my power, and this can come on the outside. So 7 log base 2 of y. Okay. So that would be using the power rule. Next, we have the quotient rule. So remember, with exponents, when we divide bases with powers, we subtract the powers. So if we have division inside of our logarithm, we can break that up into subtraction. Okay. So express as a difference of logarithm. So part A, we have log base q of g divided by 8. So this would be like m and n. So we can write that as subtraction. Log base q of g minus log base q of n. And this is all you would have to do for that one. Okay. Part B, we have ln of x divided by u. Ln, you just keep it as ln. You don't necessarily change it to log base e. So when we're working with this, we would have ln of x minus ln of u. And that's again because we have division, and we can write that as subtraction. Thank you for watching. If you have any questions, feel free to reach out to me.